last wrapping question for tonight. What is the mass of an electron in atomic mass units? Now, funny enough, this is also a conversion question. Ta-da! So, question 10, we are converting mass of electron, okay, and we want in AMU. So the mass of electrons usually comes in kilograms as reference. This is typically, and the we want atomic mass units as the top. Okay, so with that, you're probably wondering two things. What is the mass of an electron? And what is an atomic mass unit, aka AMU? So let's take a deep dive in both. Mass of electron, simply put, I have been taking a lot of chemistry courses, and knowing that by heart was not one of my required knowledge. I believe it only became truly required when dealing with physics and all the complications there. So hopefully they also don't require that of you, and they've given you a second type of conversion sheet, or more specifically they're giving you it's kind of called a constant sheet, where they give you common constants and values that you typically use in chemistry or physics. Here we actually even have atomic mass unit as well. Mass of an electron. Well, that's not fun. They give us the answer as well. Let's say they only gave us the grams. Okay, so like I said, it's usually in kilograms, but in this case it's in grams. Okay, and with now adjust and still try to solve the question. So the mass of an electron, okay, according to this, is 9.109383 times 10 to a negative 28 grams. Alright, so that's the mass of an electron. Now what is an atomic mass unit? What does this mean? So now, funny enough, right? You know how people always refer to, well, carbon. So if you actually look at the periodic table, when you try to get, in a sense, the value of how to put this, 1 unit of an element, you're probably thinking like, oh, hydrogen would probably be the best bet because it has 1 proton, 1 neutron, 1 electron. But as research has shown, carbon is actually considered one of the most, how do I put this, perfect elements in terms of like referring things specifically in terms of mass. Really, a lot of the periodic table is actually based on, if I remember correctly, it would either be carbon or, yeah, I believe it's carbon. But the point being is that the atomic mass unit specifically, funny enough, is instead of just saying how much a hydrogen weighs, I'm pretty sure because that would also be a lot hard to do, they decided to figure out, based on, you know, the in terms of this, the molecular formula and the molecular weight of carbon, right? They divided that by 12 in terms of the mass of it. For 1 carbon, they divided by 12 to be able to get that number. So the atomic mass unit, if you see here, this 1.660539, this is actually referring to 1/12 of a carbon molecule. So that's just a fun fact, but point being is that we do need it. 0.5390. That's a big number. Let me stop the 9. Let's make it 9. 1 times 10 to the negative 24 grams. And the reason why I say this is a conversion question is because they show right here 1 unit. Okay, so 1 unit is this many grams. And there. So now we have the mass of an electron. Oh wow, I really like this feature actually. And we just plug it in because you notice these two cancel out. And once you make these two numbers, in a sense, fight, I guess, because they're quite tiny numbers to the negative 28 and negative 24, make sure you put into your calculator the right way. 109 3 by, oops, let me make sure, 9.109383 divided by 1.660539. Oh, divided by 60. Okay. 10 to the negative 28 minus 10 to the negative 24. So that'll be left over 4, but pretty much the answer you get is 5. Actually write it in red so it's distinguishable. 5.486 around there times 10 to the negative 4 atomic mass units for 1 electron. That is how much it takes up. So funny enough, when you actually now go over to the mass of the electron, what do we get? 5.486. Funny enough, that is the answer right there. So they actually already gave us there, but just in case it doesn't give you the atomic mass units and just gives you the mass in terms of grams, and they give you then a separate section with the AMU, that's the conversion you take. So this is another conversion question in a sense. So with that, just double checking we have everything. How they solve it? Yep, 5.48 rounded 6 to 4th decimal place over. So that's 10 to the negative 4. This is correct. Now, before I submit this question, I do want to go back because a lot of these questions were just conversion and then one doohickey giant question about S, P, D, and F. This is the one I want to review because specifically these questions do come up in terms of electron configuration. I would say once you get to that unit, it does come up quite frequently in terms of trying to establish what that element is configured as. So the important thing is, as they did say in this nice picture here, just to mark it as different sections, the S is the first 2 rows of the periodic table, okay? The alkali and alkaline earth metals, all right? And the only exception to that, as in the only addition to that, is helium. Helium is 2s2, not 1s2, 1p1. I mean, not 1s. Whoops, sorry. Helium is 1s2 because it's the first row, as you can see here. Helium right there. Okay. So helium you write as 1s2. It is not 1s1, 1p1. Okay, just because it's on that side. That's why I kind of just throw it in there. So this is not correct. Now, moving on to the P, starting at, as I said, row 13, boron, over to neon. So we do not include helium. That is the P. Okay. These are the P elements. All right. So, with that, neon, as I said, the way you'd write that, let me see if I wrote it. I did write it. There we go. Neon nope, that's for fluorine. I wrote it down somewhere. Well, I'll just write it down again. So this one here is an example of helium. It's just 1s2. Neon Okay, if you want to write down the full thing, you have to include the 1s2, but you just start a helium, and then you go over the now second row, so that's 2s2, because it includes the 2 lithium and beryllium, so the first 2 elements of those rows, the alkali and alkaline earth metals. Okay, and then 2p6. This right here will be neon. Okay, and fluorine, and that's the one I had up there, but pretty much if we had fluorine, okay, it would still be the helium. Okay, and the first 2 rows would be filled indeed, and it will be 2p5. And if I remember correctly, there are ways to distinguish in terms of like which ones they would prefer to have full, but that's not what we're going into. We're just kind of explaining how each electron configuration matches in terms of like the rows. So as I said, this is 13 through 18, and I'm put asterisk here as to say not included helium. Okay, because helium is over here, helium is here. All right, and now D, the D shells, the D rows, okay, they're these ones right here. Okay, so these ones are known as the transition metals typically. So from 3 to 12. Okay, 1 and 2, 3 to 12, 13 through 18. Okay, 3 to 12. And as an example, if you want to run that one back, let's say you want to iron again. Okay, so iron, this right here is what it would look like, and then the more correct method would be to organize it by, remember, because D is -1 and -1 as we discussed, because it's now whatever row you're on, you subtract 1. So we started at argon, 4s2, because potassium and calcium are filled. Okay, where do I have a 5 there? 4s2. Okay, and 3d, because we're starting at the 4th row, but it's D, so -1, 2, 3, 4, 5, 6, so 3d6, and that would be for iron. Okay, so this right here would be how you write iron. And now for the last one, the lanthanum and actinium series, they're right here, and this is where all the F shells go. Okay, and I'm really emphasizing this because I don't want anyone to be confused with how I explained it earlier. That would be an error on my part, which is why we're back on this question, and because we have a little bit extra time just going over it. So once again, like I said, that's the F series, and now we're dealing with -2. So whatever row you're on, you subtract 2. So if you want to pick uranium again, so let's do that fun one again. So that'll be Rn starting, okay, and then it will be 7s2, not 7s1. Okay, Rn 7s2, and then we have 6d1, because you still have to start at actinium, and then you have 1, 2, 3, 5 F3. So that would be the actual correct one. So, and there's probably more ways to do it in terms of like how they prefer their shells to be filled, but it would go 5 because you want to make sure it's in order. 6d1, 7s2, and the reason why, because that is where the confusion for me began. Because if you notice, the only shell really that gets interrupted, like when you want to count normally on the periodic table, the only shell, as you notice here, that gets interrupted mid counting is the D shell row. Once you hit the lanthanoids and actinoids, those ones, they have a D1, but then everything after that starts being F before they get out of those series back to the transition metals. So the way it's shown here is a little bit, oh, look at that. Not what I meant to do at all, but let me refresh that. So the concept is that the lanthanum and actinium, those two count pretty much as transition metals, as that's what they classify as. And then there's like a little sliver after it, and that's where they have literally every of the lanthanum and actinium series. That's how the interruption happens, hence how we have the 1 followed by the F's that come up. And with that, that is all I have for tonight. Hopefully going over this question again has cleared up some confusion in terms of how to count it. Just remember that other than helium, the S's are the first 2 rows, the P's are the last 6 rows, the D shells are in between, so 3 to 12, sorry, and then the F is just the lanthanum and actinium series, not including lanthanum and actinium themselves, because those ones are still technically in the D shell row. Okay, some periodic tables will show that better, because they'll show like if I drew that section in the middle, they would have the LA and AC, and then right here, this is where they branch off. So kind of look like that, and then this is where they branch off to the rest of the series, hence why LA and AC are still there. But yeah, thanks for staying with me through this whole tutoring session. I just want to thank you again. With that, hope you have a wonderful rest of the evening. Happy holidays once again, and have a good night. Okay.